Dawn, 7th of June 1944, Arromanches-les-Bains, Normandy. A cool mist lifts from the channel, smelling of salt and cordite. German sentries of the 716 Infantry Division raise binoculars from the cliff line expecting wreckage. Instead they freeze. Where open water had been last night, a crooked chain of ship hulls now fences the surf, and beyond it squat rectangles stand upon the sea. The tide that battered the beaches now laps a sheltered pool where boats cluster, engines ticking, as if a harbour had grown overnight. As the light strengthens, the outlines harden. Obsolete merchantmen have been scuttled nose to tail into a curving gooseberry breakwater, their masts set like stakes. Outside them ride cruciform bombardons, floating breakwaters shackled into a screen. Inside, Royal Engineers coax pontoon causeways and the first lengths of whale roadway toward squat pierheads on spud legs. Concrete phoenix caissons, hollow fortresses weighing thousands of tons, loom on the horizon awaiting position. Through field glasses, the sentries glimpse vehicles rolling ashore and the gantries that feed them. What should be open sea has become streets of steel aligned to the tide. Signals jump from Caen to Cherbourg. The enemy has raised harbours on the sea. By mid-morning, coasters and LSTs unload onto floating quays as if docking at a finished town. Within days it will feed a vast army. To see why, we turn to the problem that forced it: assaulting Europe without a port. Winter 1943 London. The city was still dark under blackout curtains when Allied planners crowded into the subterranean war rooms beneath Whitehall. Maps of France lay pinned under lamplight, marked with red string and code names: Overlord, Neptune, Omaha, Juno. Every arrow that crossed the channel ran aground against one brutal truth: ports. To conquer Europe, the Allies needed to feed and fuel an army of 1 million men. Calculations scrawled across chalkboards spoke in tons and tides: 12,000 tons of supplies per day, or the invasion would starve on its own beaches. Yet every deep water harbour on the French coast was locked behind the steel shutters of the Atlantic Wall. Cherbourg and Le Havre bristled with coastal artillery, 240 mm guns that could turn any landing craft into twisted scrap before it reached the docks. Calais lay too close to the Pas-de-Calais guns. Even if captured, its quays would be under constant bombardment. The memory of Dieppe hung over every discussion like a wound. In August 1942, nearly 4,000 Allied troops had fallen or been captured, attempting to seize that single port. Tanks drowned in shingle, engineers were cut down before reaching the seawall, and ships burned offshore. The verdict was clear: attacking a port head-on was suicide. Prime Minister Churchill, pacing with cigar in hand, called Europe a continent without a door. He demanded one be built. Ideas surfaced and sank in turn: portable piers, concrete barges, tidal bridges, artificial breakwaters. Many dismissed them as fantasy. How could anyone construct and anchor entire harbours under enemy guns and the temper of the Channel? Yet among the doubters were visionaries. Engineers like Major Alan Beckett and civil designer Hugh Ioris Hughes, who began sketching floating roadways on scraps of paper and believing the impossible might be done. By spring 1943, necessity had become mandate. The planners of Overlord agreed. No port could be captured intact, so new ones must be made. The directive went out: build harbours where there are none. From that command would rise the blueprint for one of the boldest engineering feats in military history. Autumn 1943, at a discreet yard on the Firth of Clyde, a wartime curiosity from Winston Churchill's notebooks was given engines, drawings, and a deadline. Churchill's 1917 memorandum about temporary piers was dug from the files and elevated into policy. If the continent refused its ports, the Allies would manufacture harbours at sea. The Combined Operations Experimental Establishment became a cramped, fevered workshop where naval architects, civil engineers, and military logisticians traded models and arguments. Brigadier Bruce White sketched overall layouts, while Major Alan Beckett concentrated on practical, repairable solutions. Scale trials in Scottish lochs tested responses to real waves and real wind. Every failure taught a rule: the caisson that leaked, the roadway that flexed too much, the spud leg that jammed, and engineers iterated until designs could be specified. Measured and repeated, from those trials 3 interlocking systems emerged. Phoenix caissons were conceived as enormous, hollow, reinforced concrete boxes that could be towed across the channel and sunk to form a solid breakwater. Engineers ran meticulous calculations to ensure each section would remain intact under Atlantic storms once ballasted. Whale roadways solved the vexing mobility problem, a modular string of steel spans and pontoon supports that would yield with the tide but carry loaded 20-ton lorries from ship to shore. Spud pierheads rode on adjustable legs, spuds that could be jacked up and down to follow tidal motion, giving floating quays the steadiness needed for cranes and heavy offloading. The combination was novel: a floating outer shield of caissons anchored roadways and adjustable pierheads linking ships to land, as if a new town had been grafted onto the sea. Design alone could not win the day. Production and secrecy were the real tests. Shipyards and concrete works across Britain were quietly retooled, components coded as seawall sections, and assembly rehearsals carried out in sheltered waters until towing. Mating and sinking procedures became routine. German intelligence intercepted fragments and sometimes mocked the idea as impossible. But by late 1943, the Mulberry concept had moved from speculation to an industrial program with delivery schedules and towing trials, a gamble that now demanded mass manufacture and clandestine movement into position. This success in design set the stage for the next, even harder phase, the covert production and perilous transport of the Mulberry pieces to the invasion armada. January 1944, Britain groaned like one vast shipyard. The hum of welding torches and the clang of steel echoed from Glasgow to Portsmouth. Every estuary, quarry and foundry had been conscripted into a single secret project, to build harbours for an invasion no one dared name aloud. Over 600,000 tons of concrete and 500,000 tons of steel were requisitioned by the Ministry of Supply. The Thames, Clyde, Tyne and Bristol channels turned into production arteries. In coastal dry docks, the first Phoenix caissons rose, towering grey monoliths of reinforced concrete, some 60 metres long and weighing up to 6,000 tons. They were built like ships, yet destined never to sail, only to sink into place off the French coast and form the backbone of floating fortresses. Across the countryside, smaller factories hammered together whale roadway sections, steel trusses linked by floating pontoons, inspired by the battlefield Bailey Bridge. They were assembled in fields under camouflage netting, each marked with innocuous tags reading Seawall Section Number Basse Paupier. Entire towns became construction zones after dark. Southampton's quays, Portsmouth's shipyards and secret works at Conwy and Garleyston all laboured beneath blackout lamps. More than 45,000 men and women, engineers, dockhands, welders, masons, and members of the Women's Royal Naval Service worked in shifts around the clock, often with no clear idea of what they were making. Even across the Atlantic, American industry joined in, producing spud pierheads and floating pontoons built to British drawings and shipped under Lend-Lease. Everything was numbered, catalogued and dispersed along the southern coast of England, from Selsey to Dungeness, so that no single bomb or spy could reveal the whole. By late May 1944, more than 400 major components lay hidden in river mouths and estuaries, ready for towing once the invasion began. Watching the last massive caisson slide into the Thames, one officer scribbled in his log, "If this fails, the invasion dies." Ahead loomed the moment of truth when steel, tide, and war would collide off Normandy. June 6, 1944, before dawn the sea off Normandy boiled with movement. The largest invasion armada in history stretched from horizon to horizon, more than 5,000 vessels surging through rough water under a low grey sky. The thunder of naval guns rolled across the waves as landing craft bucked toward shore, their ramps clattering open into chaos. At Omaha, Utah, Gold, Juneau and Sword Beaches, 156,000 Allied soldiers poured onto the sand through fire and spray. Men fell, rose and pressed forward under mortar bursts and the rattle of MG-42s. By mid-morning, the beachheads were littered with burning tanks, wrecked craft and bodies, but footholds had been won. Behind the assault troops came others not armed for battle, but for construction. Engineers, bulldozer crews and logistics officers carrying blueprints instead of rifles. Their orders were clear: make ready for the harbours that would feed the entire invasion. The first trickle of supplies came in on rhino ferries, floating platforms of steel pontoons driven by outboard motors, and on lumbering amphibious trucks, DUKWs that waddled through surf like strange sea beasts. They hauled ammunition, rations, and medical kits, but the beaches soon clogged with wreckage and mud. The tide swallowed vehicles, wrecked craft piled high, and officers shouted for space. Without a deep water port, the lifeline of Overlord risked choking in its first day. Far out in the Channel, another convoy approached, the harbour itself. Royal Navy tugs strained at lines, towing Phoenix caissons, whale roadways, and spud pierheads across 70 miles of rough sea. They arrived off the beaches at dawn on June 7th, even as German artillery still probed from inland ridges. From their lookout posts above Arromanches, men of the 716th Infantry Division peered through smoke and disbelief, radioing reports of strange steel islands appearing on the sea. They did not yet realize these shapes would become the arteries of the invasion, the Mulberry harbors, the ports that would turn chaos into momentum. Between June 7th and June 9th, 1944, the impossible began to take shape on the grey waters off Normandy. Under a sky still smeared with smoke from the invasion, Allied engineers, divers, and tug crews worked without pause, guided by signals lamps, and shouted orders over the roar of surf and shellfire. The sea itself became a construction yard. For the Americans off Omaha Beach, Mulberry A took form. Off Arromanches, the British built Mulberry B, over 300 vessels, and thousands of men laboured in shifts, fighting both tide and enemy to anchor the first artificial harbours in history while war still raged. Around them, the first Phoenix caissons, massive hollow fortresses of concrete, were towed into position and flooded to sink in precise alignment, forming a protective spine against the Channel's waves. Around them, floating bombardons, giant cruciform barriers, were chained into place to dissipate swells. Behind this new wall, the sea calmed enough for cranes and pontoons to operate. From there, whale-floating roadways were laid outward from the beaches, their steel spans riding on pontoons that flexed gently with the tide. Spud pierheads rose at the ends, self-adjusting platforms on 4 great legs, where Liberty ships could berth and unload tanks, trucks and crates of ammunition straight onto Normandy soil. German artillery occasionally found the range, and Luftwaffe raids screamed low over the Channel, but the work never stopped. By June 14th, Liberty ships were unloading directly onto the Mulberries. Allied commanders stared in disbelief as entire convoys offloaded onto what only a week earlier had been open sea. German reconnaissance photographs sent to Berlin showed what looked like complete ports sprouting from the waves. But the Oberkommando der Wehrmacht dismissed them as Allied trickery until frontline officers confirmed the truth. By D+10, Mulberry B alone was processing 7,000 tons of supplies a day, enough to sustain an entire army corps. The enemy had been outbuilt, outthought, and outpaced. Yet beyond the horizon, the weather was turning, an Atlantic storm gathering strength, ready to test the limits of human engineering. June 19, 1944, 10 days after the Mulberries had come alive, the sea that had carried the invasion turned on it with fury. The weather forecast, which had barely granted the brief calm of D-Day, now betrayed them. A low-pressure system roared in from the Atlantic, dragging with it winds of 65 miles an hour and waves higher than 20 feet. By mid-morning, the Normandy coast was a cauldron. Landing craft were hurled onto the sand like toys. Hankered ships strained at their hawsers until cables snapped like whipcord. The artificial harbours, still incomplete, their moorings untested, faced the worst Channel storm in 40 years. At Omaha Beach, Mulberry A took the full blow head-on. The great Phoenix caissons, each weighing thousands of tons, heaved against one another until concrete split and steel reinforcements snapped. Whale roadways twisted like ribbon under the pounding surf. Pontoon anchors dragged free and slammed against one another in the storm-torn current. American engineers worked waist-deep in freezing water, trying to cut loose shattered spans before they tore the rest apart. But the sea was merciless. By June 22nd, when the winds finally relented, Mulberry A was gone, its remains scattered across the beaches it had served. To the east at Arromanches, Mulberry B fared better. Its builders had chosen the site well, a crescent bay that blunted the worst of the storm, and its components had been reinforced with extra anchors and heavier moorings. Though battered and partially dismantled, the British harbour held. German spotters on the cliffs watched the devastation and radioed jubilant reports that the enemy's floating ports had been destroyed. Yet within days, Allied engineers were back in the water, patching breaches, reballasting caissons, and welding new whale spans into place. By early July, Mulberry B, now affectionately called Port Winston, was unloading more than 6,000 tons of cargo each day. The storm had shown how fragile the miracle was, but also how unstoppable. With one harbour left standing, the road to France remained open. For the German High Command, the site defied logic. In late June 1944, reconnaissance aircraft returning from Normandy brought back photographs that stunned the analysts at Saint-Germain-en-Laye. Massive rectangular shadows stretching from the French coast into the sea, ships moored alongside, cranes swinging over the water. What had been open beach 10 days earlier now appeared as a full harbour. The Abwehr had heard faint rumours the previous year, British trials with floating bridges somewhere in Scotland, but those reports had been dismissed as fantasy. The Führer's engineers had assured him that no army could build and sustain a port in open water. Yet the evidence now lay in the grainy images spread across the situation tables. Field Marshal Rommel's staff described the phenomena in bewildered detail. Artificial islands anchored to the coast, harbours without foundations. Naval engineers in Cherbourg tried to reverse engineer what they saw, calculating that such constructions should have required at least 6 months of work and thousands of tons of steel and concrete. Their conclusion was impossible. The Allies had assembled, launched, and made operational entire ports within a week. It meant that the vaunted Atlantic Wall, designed to starve an invasion before it could establish supply lines, had already failed. In Berlin, propaganda officials quietly ordered the news suppressed. German troops on the coast were forbidden to discuss the harbours. Luftwaffe crews were told to refer to them only as temporary docks. Morale wavered as word spread that the enemy could manufacture what nature had denied them. Attempts to destroy the Mulberries followed. E-boat raids under cover of night, sporadic bombing runs from what remained of the Luftwaffe, but Allied air cover and naval patrols made every strike futile. One internal Kriegsmarine memorandum called the Mulberry Operation the greatest technical surprise since the discovery of radar. From that moment onward, the German command realized the Allies were not just superior in numbers, but in imagination itself. Their next offense would have to be against an army that could build miracles, and it would begin at Cherbourg. By mid-July 1944, Mulberry B at Arromanches had become the living artery of Operation Overlord, a man-made port that pulsed day and night with the lifeblood of the invasion. From the air it looked like an industrial city floating on the sea, a 5-mile semicircle of concrete and steel, its 146 Phoenix caissons forming a vast breakwater where whitecaps broke harmlessly against grey walls. Inside this shield, whale roadways flexed with the tide, connecting 10 spud pierheads to the beaches. The quays rattled under the weight of trucks, tanks and cranes that swung in perfect rhythm, unloading the endless cargo that sustained an army. The harbour ran with the precision of a great machine. Liberty ships and coasters arrived at dawn in staggered convoys, their holds packed with rations, ammunition and fuel. By afternoon, cranes had emptied them, and by nightfall the ships were already steaming back to Britain for another load. Military engineers and naval crews kept the system alive through wind, rain and enemy shelling, diving to repair fractured pontoons or welding whale spans back together even as artillery rumbled inland. Despite being built in weeks, Mulberry B handled tonnage rivaling major ports like Southampton or Liverpool. For soldiers fighting around Caen and Saint-Lô, every bullet, every bandage and every drop of petrol could be traced back to the artificial harbour at Arromanches. It was a triumph not of firepower, but of logistics, a steady, silent miracle that turned the beaches into a permanent front-line port. German counterattacks aimed to sever this lifeline, but Allied control of sea and air rendered their efforts futile. By the end of July, over 1 million men and 500,000 vehicles had passed through Mulberry B, fueling the build-up for Operation Cobra, the great breakout into France. The floating harbour had done its work. It had made invasion into liberation. By late July 1944, the Mulberry Harbour at Arromanches had become more than an engineering triumph. It was a symbol of inevitability. For exhausted Allied troops pushing through the Norman bocage, caked in mud and hemmed in by hedgerows, the distant sight of Liberty ships unloading supplies onto the sea's surface felt almost divine. Men who trudged inland for days turned back to glimpse the floating city that never slept. A skyline of cranes, quays, and pontoons glittering under flares and moonlight. It whispered a single message: reinforcements would always come. It was like seeing a city built on water, one British sapper recalled. You couldn't look at it and not believe we were going to win. For the Germans, that same vision hollowed morale. The Atlantic Wall, the great stone promise of invincibility, had been outflanked by steel and imagination. Reports from captured Wehrmacht engineers spoke of disbelief, claims that the Allies had mastered some new science or an act of sorcery. A staff memorandum from Rommel's command admitted that the enemy had conquered the sea itself. When twice he went, Field Marshal Rommel was gravely injured by Allied aircraft in mid-July. He reportedly muttered that the fortifications he had built were useless now. Our walls are useless if the sea itself is conquered. This contrast between German destruction and Allied creation was more than tactical. It became psychological warfare made visible. The Mulberry Harbour turned the beaches from temporary landing grounds into monuments of endurance. To the troops of occupied Europe, the sight of Allied ships docking on the very shore of Hitler's fortress was proof that liberation was not a rumor, but a process already underway. By August 1944, the floating port that had begun as a desperate gamble had become both symbol and weapon, a testament that steel, ingenuity, and will could overcome any wall of stone. The Mulberry Harbours reshaped not only the Normandy campaign, but the very logic of invasion itself. For the first time in history, an army did not have to seize a port before it could be supplied. It built one where none existed. Strategically, this was revolutionary. Traditional doctrine dictated that logistics followed conquest. With Mulberry, logistics led it. When Cherbourg finally fell on June 27, 1944, Allied troops found its docks gutted, cranes demolished, and entrances mined. Yet the loss mattered little. By then, Mulberry B at Arromanches was already landing thousands of tons of ammunition, fuel, and rations every day. The Allied advance no longer depended on geography. It depended on ingenuity. This floating port granted General Eisenhower and his planners unprecedented freedom of movement. Divisions could be fed, refueled, and reinforced directly from Britain without waiting for French ports to be repaired. By the time Operation Cobra began on July 25th, tearing open the German lines near Saint-Lô, every shell that thundered across the bocage had likely crossed the sea via Port Winston. It was a logistical miracle that turned the invasion from a precarious beachhead into a rolling offensive. The Germans, who had expected the Allies to stall for lack of infrastructure, instead faced an enemy who had made the sea itself an extension of its supply network. By September, with the capture of Antwerp and Le Havre restoring traditional ports, the Mulberry's task was complete. Many of their sections were dismantled and repurposed, their work done but their lesson permanent. Post-war studies by both Allied and German analysts called them a decisive logistical factor. The concept, mobile, modular, and resilient, had rewritten amphibious warfare. Yet it also exposed the vulnerabilities of such marvels to storms, corrosion, and strain, setting the stage for future innovations. The next question was clear. How could the miracle of Normandy be refined and repeated elsewhere? Though the Mulberry Harbours had triumphed in purpose, they remained at the mercy of the sea that had both carried and cursed them. The June storm had been a brutal teacher, revealing how even the boldest human designs bent before the raw power of nature. From that day onward, the engineers at Arromanches waged a quieter, relentless battle, not against the Germans, but against corrosion, waves, and mechanical fatigue. Whale roadways groaned under the unending weight of trucks and tanks, their hinges wearing thin. Pontoon joints split, mooring cables frayed, and spud pierheads jammed in shifting tides. Each repair demanded men to dive into cold, fuel-streaked waters or weld at night beneath tracer fire, keeping the miracle alive one seam at a time. The upkeep was immense. Thousands of man-hours each week went into re-anchoring caissons, replacing pontoons, and reinforcing sections battered by constant motion. Allied naval architects studied every failure in meticulous detail. They found that the steel spans suffered from fatigue where tide and traffic met, that concrete caissons cracked along predictable stress lines, that hydrodynamic drag could be reduced by reshaping pontoons. These insights transformed makeshift wartime improvisation into a science. The experience directly influenced the design of Bailey bridges used to cross Europe's rivers, and later, the post-war repurposing of Phoenix units for rebuilding civilian harbors from France to Holland. By documenting every flaw and breakthrough, the Mulberry engineers created a new doctrine of amphibious logistics, flexible, modular, and adaptive. Their notes would inform Allied naval design for decades, echoed later in floating causeways during the Korean War and in temporary harbors during the Falklands campaign. As victory drew near and the great harbor at Arromanches was dismantled piece by piece, only traces remained on the tide-worn shore. Yet the lessons endured. That engineering genius must always bow to the sea and learn from it. When the guns finally fell silent in 1945, the Mulberry harbors had already written their chapter in history, and yet their story was only beginning. Along the Normandy coast, the sea reclaimed much of what had been built in secret and assembled in fury. Many of the massive Phoenix caissons were salvaged and towed away to rebuild shattered European ports. Others were simply left in place, half submerged, where they still stand today at Arromanches, barnacled and wave-worn, monuments of steel and salt to an age of impossible invention. At low tide, their silhouettes rise like broken battlements, silent reminders of a time when engineering itself became a weapon of liberation. In the post-war years, engineers and planners from every major maritime nation studied the Mulberry design. British and American reports circulated through universities, shipyards, and ministries. The lessons learned from its modular roadways and floating pierheads directly shaped post-war reconstruction. Phoenix units were reused to rebuild docks at Le Havre and Rotterdam. During the Suez Crisis of 1956, rapid deployment harbors borrowed heavily from Mulberry principles. Its concepts even echoed decades later in offshore oil platforms and disaster relief pontoon systems from Bangladesh to the Philippines. The idea that you could build a harbor anywhere, anytime, had moved from wartime improvisation to peacetime doctrine. For the men who had welded, poured and towed those enormous structures, pride remained lifelong. Many spoke of standing on those floating quays as liberty ships offloaded under fire, knowing they were part of something history had never seen before. German officers, reflecting years later, conceded that they had underestimated the enemy's imagination. The Mulberry harbors proved that creativity could be as decisive as courage, that innovation could breach walls no artillery could crack. Today, the remnants at Arromanches endure not as relics of war but as enduring blueprints for human ingenuity, proof that necessity, imagination, and courage can build miracles upon the sea.